Alright, so this is, I guess, installment one of the astronomy unit for extra credit. So this one's entitled Earth in Space, and let's just get right to it. Now keep in mind you need a piece of paper out, and you're going to format this the way we do in notes in class, in Cornell format, whatever you see on the left, right on the left, whatever you see on the right, right on the right, any sort of other notes that may help you on the test that you see in the video that I didn't require that you write down would probably be a good idea for you to write down. So let's get to it. So first off, when we're talking about Earth in space, we need to talk about simply how the Earth moves in space. So first off is rotation. Now, what rotation is in terms of when we're talking about the Earth is the spinning of Earth on its axis. So it is the spinning of Earth on its axis. Now, on the picture that you see on the bottom left is a picture of our Earth. Now, you can see that there's an imaginary pole right through the middle of it. And what rotation basically explains is that the Earth is basically spinning around that axis in that direction. So, in that sort of direction, that's the way the Earth spins, right around its axis. Now, you'll notice that the axis isn't straight up and down, it's actually tilted. Now that plays a role in what we're going to talk about in a little bit in terms of some of the things that would create on Earth that we have to deal with because of the Earth's tilted axis. So rotation is the spinning of Earth on its axis. Relatively straightforward. Now, rotation is a little different than revolution. I understand that both words start with an R, but please don't get them mixed up. When we're talking about rotation, it's the spinning of Earth around its axis. When we're talking about revolution, revolution is the movement of one object around another. So in talking about Earth, it's the movement of Earth around around its star, which would be the sun. So the movement of Earth You're going to have to forgive my writing, as I know it's not the neatest, but at least it's legible, unlike some of you. I'm not going to name names. I should, but I won't. So revolution is the movement of Earth around the sun. So you can see by the arrow kind of shown here that is revolution. The fact that the Earth revolves around the sun. Now you'll see that when we're talking about revolution over here, it says that the orbit or the revolution of the Earth around the sun takes 365.25 days. That's roughly the time of a year. Now, the reason we have a leap year, or an extra day added onto a year every 4 years, is to basically account for the 0.25. So if you have 0.25 every year, then after 4 years it becomes one whole day. That's why every 4 years we have one extra day added onto the year. Now, if it's hard for you to remember which year is a leap year, it's basically the year that we have the Summer Olympics. So that was in 2012, which was last year, was a leap year. Now, you can also see, shown in the picture, that the rotation of Earth around its axis takes 24 hours. 24 hours being the time it takes for one day to complete. So that's where we get basically our timing from in terms of days and years. It takes 24 hours for the Earth to rotate around its axis one full time, and it takes 365.25 days, or 1 year, for the Earth to revolve all the way around the Sun. Now, moving on. What causes the seasons to occur on Earth? Well, this is where the Earth's tilted axis comes into play. So you can see that the Earth tilts on an axis about 23.5 degrees away from perpendicular. So that is what accounts for the Earth's seasons, is the tilted axis of the Earth. The key word here being tilted. Because if it wasn't tilted, then we wouldn't have the same seasons that we do. But because the Earth is tilted, that causes us to have winter, summer, spring, and fall. So, what causes the seasons to occur on Earth? It's the tilted axis of the Earth. Now, keep in mind, as you're making these notes, at any point you can obviously pause the video if you need more time to copy something down, and you can always click back if you need to review anything. So it's the tilted axis of the Earth. Well, what do I mean by that? Well, let me explain by showing you this next picture. So here's another image of the Earth revolving around the Sun. Now we'll start from the left, which over here, which we call the winter solstice. Now I can see that it's hard to read, but if you kind of follow along with what I'm saying, it'll be relatively easy. So the winter solstice happens on December 21st of every year. That's when the Earth's North Pole is farthest away from the Sun. So as you can see here, the Earth's North Pole is really far away from the Sun. So during the winter solstice, or when the Earth is in this position in its orbit, this is when the northern hemisphere undergoes winter, because the northern part of the Earth is farthest away from the Sun. Conversely, you have the southern hemisphere, which is, since it's closer to the Sun, and the closest it'll get to the Sun is in summer. So when the United States and England and Europe and all those parts of the Earth have winter in December, like around winter break and Christmas time, the southern part of the Earth, or all the countries in the southern hemisphere, are having summer. That's why you get, for instance, Australia, they celebrate Christmas with barbecues, as opposed to us when we associate Christmas with snow and rain and cold. In Australia, it's hot, so they have Christmas with barbecues. And conversely, on the other side, on the right side, we have summer solstice. That's when the southern hemisphere is farthest away from the Sun, and the northern hemisphere is the closest it'll get to the Sun. So during this time, as you can imagine, the northern part of the Earth would be in its summer stage, and the southern part of the Earth would be in its winter stage. Now this is in June, specifically June 21st. Now, another thing that'll be of note is during this time, let's say summer solstice for instance, the North Pole never sees darkness. It's sunlight 24 hours a day for a short amount of time on the northern pole, because that axis, since it's tilted, is never not facing the Sun. Conversely, the South Pole during December and the winter solstice never sees darkness. And during the winter solstice, the northern pole never sees the Sun. So it'll be a long period of time with absolutely no sun. It'll just be dark the entire 24 hours. It's basically weeks leading up to, I believe it's a little over a month that the the North Pole won't see the sun. Okay. So in any case, that's basically it. The other term you may need to know or may not is the equinox. The two equinoxes simply mean that it's in between the two solstices. So you can see here this in the autumnal equinox, it's halfway in between winter and summer solstice, and the same thing with the equinox down here, again between winter and summer solstice. Alright, so that's basically it in terms of this one. Relatively short. It shouldn't have even taken a page because I only required that you do 3 of them. Make sure that you write your 2-sentence summary at the bottom of the page, and you will connect the notes coming up to this paper going forward. If you have any questions, go ahead and ask me in class, although I won't go into anything in terms of astronomy too in depth because this is an out of class activity. Alright, have a good one, and we'll see you on Monday.